1989 sextillion coup. 1989 followed by 21 zeros. That's the mass of the Sun, and if you make it 2 to 4 million times more, it becomes the mass of a black hole. No wonder why they have an unthinkably strong pull that can even trap the fastest thing in the universe, light. Lately, scientists have found out that black holes might have more than just dust and stuff floating around. Some people think there could be whole universes inside them. Looking into a black hole is nearly impossible due to time dilation and the destructive forces of its spinning hot gas. However, inside larger black holes, where gravity is weaker, other universes might exist. That might sound insane, but scientists studying spinning charged black holes discovered particles and even stars inside, which hint at nothing but alternate universes. Dr. Nicodemus Poplawski also theorizes that our universe originated from a singularity inside a black hole, exploding into energy and forming stars, planets, and galaxies. So, it means two basic things. One, within singularity, there's a universe like ours. And two, our universe could also be inside a black hole. But is it true? What's really there inside a black hole? Fortunately, scientists have some answers to that. In 1916, when Albert Einstein came up with the theory of general relativity, he said there might be black holes out there in space. But it wasn't until the 1960s that scientists found some proof. They were looking at the Cygnus constellation and noticed a super bright blue star shooting out X-rays. Turns out, that star was going around a huge black hole, Cygnus X1, which is about 6,000 light-years away from us. This was like a big thumbs up for Einstein's idea about black holes. The closest black hole is about 1,500 light-years away from us. In 2021, scientists finally got a good picture of a black hole. They found out it's got three parts: the event horizon, which is the point of no return, the photon sphere, where the light goes round and round before getting sucked in, and finally, the singularity, where everything gets squished into a tiny dot. At that point, the laws of physics don't work. Now, imagine if you fell into one. You'd get stretched into a thin line and torn apart before disappearing forever. This is called spaghettification. If your friend watches you from a safe distance, from your friend's point of view, you appear to slow down and suddenly you just pause as you get closer to the black hole's edge or the event horizon. But for you, inside your ship, you're going almost as fast as light toward the black hole while getting stretched more and more each moment until you get torn apart completely. And here comes the mind-boggling part. According to the laws of physics, both things are true at the same time. Your friend sees you being paused while you're speeding up and getting stretched by the black hole's gravity. Does it mean the reality splits in two? This happens because of the time dilation, as on the other side of the event horizon, time and gravity don't work the same way as in outer space. So, the basic problem is that the scientists can't study them up close. Instead, they watch the stuff around them, like radiation and dust. They can't send anything into a black hole because once it crosses the event horizon, it's game over. So, even though black holes are 3D, scientists have to study them like they're 2D puzzles. One theory says when a giant star runs out of fuel and collapses in on itself, it gets super small and super heavy until it forms a singularity, a point of infinite density. That's how black holes are formed. Particularly, stellar black holes, born from supernovae, are confirmed. They're usually measured in solar masses, with the largest ranging from 3 to 10 solar masses. For example, Cygnus X spins close to its max at 800 times per second, despite its 21 solar masses. Back in 1963, a researcher, Roy Kerr, came up with a cool idea. He thought that instead of collapsing into a point, a spinning black hole might flatten out into a disk. He called this part the Ergosphere. Kerr's idea suggested something mind-blowing. Wormholes. These are like shortcut tunnels through space-time, connecting far-off places in the universe in a blink. Imagine a circular doorway. If someone goes through it via the inside of a black hole, they might end up in a place where the rules of how things work are completely different. Just think of space-time like a flat sheet of paper. If you draw a line between 2 points on the paper, that's how objects move through space-time. But imagine folding the paper and making a quick path between those 2 points. That's a wormhole. Now, wormholes might sound like pure sci-fi, but they're actually an important idea from Einstein's theory of relativity. In fact, the other name for a wormhole is the Einstein-Rosen bridge. But we've never seen it because they're so unstable they'd collapse in a flash. If we can ever make one, it will mean black holes aren't just gobbling up everything in sight. There might also be doorways to other parts of the universe. So, now, the big question is, can we use wormholes to zoom through space and time? Well, it's not as easy as hopping in a spaceship and punching in coordinates. First off, Einstein's theory says nothing can go faster than light. That's a bummer, because it puts a speed limit on our cosmic road trip dreams. Secondly, some scientists worry wormholes might be too wobbly or blocked by stuff like radiation and dark forces we can't even see. But wait, there's hope. American physicist Michio Kaku, who's been on a quest for a theory that ties everything together, has talked about something new: Superstring Theory. This theory suggests that our universe might have started when other universes crashed into each other, or popped out of another universe like a new baby being born. It also supports the theory of wormholes connecting these universes, and stuff we see happening in our universe might be clues to these connections. It's Dr. Kaku who actually thinks maybe our whole universe is also inside a giant black hole, and the black holes we see are like portals to other worlds. This idea makes us wonder about what's really true and makes us want to explore more. So, what do you think about all this? Do you think it'd be ever possible to go inside a black hole? Drop your thoughts in the comments below. Hit the like button if you found this fascinating, and don't forget to subscribe for more mind-bending science content. Thanks for watching.